This is part 3 of section 3.4. We have just talked about Descartes' rule of signs that will help us figure out how many positive answers we might have and how many negative answers we might have. Now I want to talk to you about the upper and lower bounds theorem. This theorem is not in your book. It is not covered at all, but it is extremely useful. So if you understand this, it will help you out a whole lot. If you don't understand it, then you can just ignore it, okay? But what it's going to do when we use synthetic division, it's going to tell us possibly that we can't have an answer larger than what we chose. And so, for example, if we are testing a potential positive 0, so let's say I'm testing positive 2. And say my answer possibilities, I have a possible of 1, I have a possible 2, I have a 4, and maybe an 8. Those are my positive possible answers. If I'm checking 2 in synthetic division, and it doesn't necessarily have to work out, I might have a number as my remainder, but if I have a positive, 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 positive all the way across, even if this 2 does not work, what this is saying is if I do the synthetic division and I get positive numbers all the way across the bottom, then I know that no number larger than 2 will work. So if I'm just testing and I check 2 and I get positives all the way across the bottom, then I can also eliminate 4 and 8. Those are not going to be possible answers. So this can, if you see this and you're testing a positive number, it can cut out some of the things you need to check. Now, there's a similar thing happening with negatives. If you're testing negative 2, and then as you're testing a negative number, you end up with alternating signs on the bottom. It does not have to work out. You may have a remainder other than 0, but it does not matter whether you start with a positive or a negative. But as you're doing this, if you end up with alternating signs, whatever that is, then if you end up with, that means nothing smaller than negative 2 would work. So let's say your potential negative answers are negative 8, negative 4, negative 2, and negative 1, the opposite of what I have right here. If I check negative 2 and I end up with alternating answers, then I can eliminate everything smaller than this. So I would be able to eliminate negative 4 and negative 8 as well. So again, I'm not testing you on this, but if you keep this in mind, it can help you narrow down your answers a lot more quickly. Okay, so for these two problems, we are just asked to use Descartes' rule of signs and decide the number of possible positive and negative real number solutions. Okay, now remember for the positive solutions, we just look at f of x. But for the negative ones, we need to figure out f of negative x. So let me go ahead and do that. This is going to be negative 2 times negative x cubed plus negative x squared minus a negative x plus 7. And this is the same as, this is going to still be a negative, so that makes that a plus 2x cubed. When you square something, the negative goes away, so this is plus x squared. This is going to be plus x plus 7. Okay, so let's look for the number of positive answers, the number of potential positive solutions. We look at regular f of x for this, and we count the number of sign changes. I go from a negative to a positive, so that's 1 sign change. And then positive to a negative, that's 2. And then negative to positive, that's 3. So I have 3, or remember you keep subtracting 2 until you can't. So I have 3 or 1 possible positive solutions. Okay, so let's check the number of negative solutions. We look at the sign changes for f of negative x. Well, all of these are positive, right? There are no sign changes. So I know that I have no negative solutions. So what that would do for me is if I have a list of potential solutions, I just eliminated half of them because I know none of the negatives are going to work. And all I would need to do is to check the positive solutions. So this is a fairly quick check, fairly easy to do, and we get a lot of information out of it very quickly. Now remember that when you're plugging in a negative x, this changes the sign on everything with an odd exponent. If it's an even exponent, then the negative doesn't change anything. So, and that's just for this. We've talked about this before, but you don't have to necessarily write out this step if you just recognize this one little bit. Okay, so let's do the same thing here. This is my f of x. I need to find f of negative x. And keeping this in mind right here, that it changes the sign of every term with an odd exponent. This is x cubed, so this is going to be negative x cubed. This is an even exponent, so it stays the same. This has an odd exponent, so it changes. And then there's nothing to plug into here, but technically it has an even exponent because it's x to the 0 power. Okay, so the number of potential positive solutions. How many sign changes do I have here? They are all positive, so I know that I have no positive solutions to this whatsoever. Okay? Now here, how many negative solutions do I possibly have? Well, it starts off as negative, and then it goes to positive, so that's one change. And then back to negative, so that's 2. And then negative to positive, so that's 3. So I have 3, or subtract 2 to get 1. Now, a connection to make here. Remember that we learned earlier that whatever your degree is, that's how many zeros you should expect. You should always be able to get 3, like right here I have 3 or 1 and I have 0. So 3 and 0 would give me 3 solutions. 3 or 0, 3 solutions. When we were talking about the previous one, like right here, we were talking about the number of zeros here, 2 or 0, and this is 1, and we were talking about this cubic. So 2 and 1 gives me 3. You should always be able to get a 3 out of this, just to, make sure that you haven't missed anything. Okay, so let's find all zeros of the polynomial functions given. We want to use the rational zero theorem. We want to use Descartes' rule of signs. We will also keep the bounds in mind as we go along with this. So the first thing we want to do is let's do Descartes' rule of signs first. This is the same thing in this case as f of x. It just so happens that it's written equal to 0, and well, let me write this down first. Asking for the zeros of this function is the same thing as asking you to solve this equation. So this is my f of x. So f of negative x would be negative 3x cubed minus 8x squared plus 8x plus 8. I expect to get 3 answers because that's the degree. So how many possible positive solutions do I have? I'm going to count my sign changes. I go from positive to negative, so that's 1. Negative again, and then back to positive. So that's 2, or subtract 2 to get 0. So I either have 2 positive real solutions or I have 0 positive real solutions. Okay? And now let's check the number of negatives. Negative to positive, so that's 1 change, and then it stays positive. So I have 1 negative real solution. Okay, so let's start with our P and Q stuff. A naught is 8. So our P values are everything that divide evenly into 8. So that would be, of course, plus and minus on all of these. 1, 2, 4, and 8. Now, our AN is 3. So our Q values are everything that divide evenly into 3, of course, with the plus and minus. That will give me 1 and 3. So if I want to list all of my potential rational solutions, that would be all of my P over Q possibilities. Just get in a pattern and go. 1 over 1 is 1. 1 over 3 is 1/3. 2 over 1 is 2. 2 over 3 is 2/3. 4 over 1, 4 over 3. 8 over 1, and then 8 over 3. So I have a list of how many is this? That's 8 listed, so 16 possible solutions. And that is a lot, but it is still better than having an infinite number of possibilities, which is where we start off. Okay, so let's just start checking. I'm going to start off, I'm just going to check +1. Let's just see what happens. If I check +1, I need to make sure I write down my coefficients here. And they are in order and nothing got skipped, so that's a 3, -8, -8, and +8. Now I'm checking a positive number, so I'm going to keep in mind that if I end up with all positives down here, then I'll be able to eliminate everything larger than 1. So first, bring down the 3. 3 times 1 is 3, plus -8 would be -5. So I already have different signs, so I know that 1 is not an upper bound. -5 times 1 is -5. -8 plus -5 would be -13. Multiply and you get -13, and I did not get 0. I don't need to do this arithmetic here. I'm looking for a 0. And I would also go ahead and do the addition if it looked like I may have an upper bound. But as soon as I saw I did not have an upper bound because I had opposite signs, they weren't all the same sign down here, then I didn't need to do this last part. So 1 did not work. Let's jump up and try 2. And I'm using these same coefficients. Bring down the 3, multiply to get a 6, add for -2. Multiply, -4, add -12, and I don't have the same sign, so I know 2 is not an upper bound. Multiply one more time, and you get -24, and that does not give you a 0 there. So far, I have eliminated 1, and I have eliminated 2. Okay. So let's look at 4. I'm just checking my whole numbers because why not? I get 3, and -8, and -8, and +8. Bring down your 3, and I get 12. -8 plus 12 will give me a 4. 4 times 4 is 16. -8 plus 16 is 8. 8 times 4 is 32. And even though I see that I'm not getting a 0 here, I do have the same sign all the way across. So I get 40 here. So that tells me that 4 was an upper bound. And that means it also eliminates any possible solution larger than 4. So this also eliminates 8. So it is not +1, +2, +4, or +8. Okay, so that means I need to go back and check my fractions. I also would want to, if any of my fractions were a value larger than 4, I would eliminate that too. It's just we don't have anything that big. So let's check 1/3. So again, 3, -8, -8, and +8. Bring down the 3. 3 times 1/3 is 1. -8 plus 1 is -7. -7 times 1/3 is -7/3. And then if you get a common denominator or use your calculator, you will add those together and you get -31/3. And then you multiply again and you get -31/9. And that does not equal 0 there. I don't actually have to do that arithmetic. I did not have all the same sign across here, so 1/3 is not an upper bound. So let's try 2/3. Bring down your 3. 3 times 2/3 would be 2. -8 plus 2 would be -6. -6 times 2/3 would be a -4. -8 plus -4 would be -12. -12 times 2/3 is a -8, which gives me a 0. So I have one of my zeros. This was a positive 0. I either have 2 or I have zeros. So it's not 0, which means I have one more positive solution. And I should also have a negative solution. Now what I've done here, since I started off with an x cubed, this goes down to an x squared, and we know how to solve a general quadratic. So I'm going to take 3x squared minus 6x minus 12 and set that equal to 0 and solve. Now since everything here is divisible by a 3, I can reduce that so I have smaller numbers to deal with. And I end up with x squared minus 2x minus 4 is equal to 0. This does not factor, okay? And if it does not factor, that means I'm not getting rational solutions from this. I need to go to the quadratic formula, and I get x is equal to -b, so positive 2, plus or minus the square root of b squared, minus 4 times a, which is 1, times c, which is -4. And this is all over 2 times a, which is 1. And when I do the arithmetic, I get 2 plus or minus the square root of 20 divided by 2. Simplify the square root of 20, and you get 2 plus or minus 2 times the square root of 5. And you can think of this as either factoring out the 2 and then reducing it, or you can think of it as splitting it up as 2 over 2 plus or minus 2 times the square root of 5 over 2. That reduces to a 1, and the 2's reduce here. So you get 1 plus or minus the square root of 5. Okay? Now, so I have all 3 of my answers. I expect 3 answers because that was my degree. My answers are 2/3. And remember, our P over Q's only promise to give us any rational solutions we have, and it is here. These are irrational solutions, so they were never covered by the P over Q business, but they were covered by the Descartes rule of signs. I have 1 plus the square root of 5, and if you get a decimal approximation of this, you'll get a positive solution. And I also have 1 minus the square root of 5. And if you plug this in and do the arithmetic, you'll also have a negative solution. So we have exactly what was predicted.